the previous classes, we have discussed about another chapter, that is moving charges and magnetism. So where we have discussed about the effect of magnetic field. I mean, if you kept any object in the uniform magnetic field, what are the force? What is the magnetic force acting upon that current carrying conductor? Or if a loop is placed in uniform magnetic field, what is the torque acting on it? So several factors we have studied in the previous classes. But this chapter is also related to the magnetism. We have learned some of the things in the previous class which is related to the concept of magnetism. And we already know that this concept of magnetism was originated, whenever the current is flowing through in a conductor, it will produce magnetic field, and it was formed by the scientists for post. So there are a lot of scientists who work on this field of magnetism, and there are plenty of applications there in our daily life. So there are a lot of devices which work under the principle of magnetism. So now the chapter we are moving here is magnetism and the matter. So you all know that matter is a substance, and what is the relation between the magnetism and the matter? That what we are going to see in this chapter. So magnetism and the matter, actually they are here it is interrelated. So what you are going to see in this chapter is you want to see a matter as a magnet. For example, if an object, for example, if I take this chalk, if this chalk has any magnetic property, then how this magnet will react, or whether this magnet will attract, what are the properties of this magnet, how to represent these magnetic field which is given by this material. So these are all the things we have to study in this chapter. Yes. So if you look at the history of magnetism, actually the history of this magnetism, which dominate the humans, life of humans, it was there before the birth of a human. So such a history, the concept of the field of magnetism has. And if we are looking into the history of this magnetism, then we have to go for the times of Greeks. And let me tell you one incident, that it is an island in Greece, and the name of that island is Magnesia, where shepherd was there. Shepherd means the people who are taking care of the sheep. They have to feed the sheep and they have to take care of that sheep at every instant. So those shepherds actually were in the wood, and which was made from wooden, and to the bottom of that wood it was coated with metal, means iron. So when they wear that boot and when they were walking, they feel that it becomes so heavy. It means they will use this boot for a very long time. So after the usage of a very long time, they feel that these boots have become very heavy. And they observe that there are some objects which is sticking to that that metal that is coated to the bottom of their boot. And actually it is some origin of the concept of magnetism. And the matter, the substance which are sticking to that metal is because of the attractive property of magnet. We already know it. Magnet has two properties, means it will exert two kinds of forces. One attractive force, another is the repulsive force. Sometimes it will attract each other, it will attract the objects, and sometimes it will also repel the object. So that is why this is an incident which has happened in an island called Magnesia. So from that word itself, the magnet or magnetic it was originated. So that is the origin of the concept of magnetism. And at the same time, this philosophers also worked on it, worked on this property of the attracting property of this material to the metal. So they did a lot of experiments on it, and they told that this is because of concept of magnetism. And at that time they found one ore. Ore means which contains a lot of things, the substance from which something we can access. So at that time they found ore of the iron, means a metal, and it is called as a lodestone. It is called as a lodestone. Lodestone means it is a naturally occurring ore of iron. So there are several ore of irons are there, that is hematite, magnetite, limonite, siderite, different ores are there, among which lodestone are naturally occurring a ore of iron. And this concept of magnetism was successfully successfully used by the Chinese. The Chinese were actually traveling those times. It was there was no transportation properties like what we have today. We use if you want to move from one place to another, now we use cars, bikes, or anything you can use. But those days it was not there. They were always transporting through the water. I mean, they were traveling through the ships. So while traveling through the ships, these Chinese people are using some compass. You know it. So it has some needle, and it will always align in the direction of magnetic field. And they were using that compass to know the direction of magnetic field. That is a Chinese people are using that concept in their daily life. And after that, there was some Chinese emperor. Emperor means he's a king. He is not a king. He is emperor. Emperor was using this technology to find the people in a fog condition. So fog condition, nobody can see the people or the direction in which the people are coming. And those days, the emperor were using this compass to know the direction and to attack some other kingdoms. So this is also a practical application of this concept of magnetism in the olden days. So this is some history of this concept of magnetism. And after that, even Newton also was fascinated by this magnet. When he was a child, he was given a piece of magnet when he was little, and he was always looking at its repulsive and attractive nature. He was just taking that magnet to some other metals. It was just sticking to it. It was attracting it. But sometimes it was wrinkling. So he was very was attracted towards that magnet. Because see, when you take a magnet to any object, there is no need to be contact between it. Still, that will attract or sometimes it will repel. That is why he was very fascinated about this concept of magnetism. So this is a basic knowledge about this concept of magnetism. And if you say, or for example, if I am asked, what is the best example for a magnet? It is nothing but our Earth. Earth itself will act like a magnet. The Earth has a one bar magnet. It will align in one particular direction. So because of that reason, I mean, since the Earth is acting as a magnet, these compasses are working because they will always align in the direction of north and south. Since the Earth has this magnetic property. So this is the best example we can give for anyone for a magnet, that is the Earth. And in laboratory, in our lower classes, you might have studied about the bar magnet. So this is bar magnet means it is a piece of magnet. See, there are naturally occurring magnets are there, and you can also make a magnet. There are different kinds of magnets you can make, namely electromagnets. So permanent magnets are there. So these are some of the types of magnets you can see. Yes. So I'm telling about the bar magnet, and if you take the bar magnet, what you can observe is you can see the two poles. So this is actually found by some experimentation did by the scientists, and they found that that magnet has two ends, like we have observed in the electric dipole. So in the electric dipole means in electric dipole it has two poles. One is a positive charge and a negative charge. They are separated by some distance. In the similar way, the bar magnet has also two poles. And in order to, in the concept of electrostatics, we have drawn the electric fields for a dipole. And it was originated from positive charge, and it will terminate or end at the negative charge. But when you come to the concept of magnetism, you cannot say like the field lines will start from one end and it will end at the another end. You cannot say that. Rather, waveform you also do. So these are the some of the properties of the bar magnet. So now let's see some properties of these bar magnet, and let's also see some properties of magnetic fields. So in the beginning, let me say some properties of bar magnet. So if we consider any bar magnet, it will have two poles. One is a north pole, another one is a south pole. If you take any bar magnet, it will have two poles. One is a north pole, another one is a south pole. So two poles it has. So which will look like a magnetic dipole. So two poles are. And if you wanted to separate this magnetic poles, I mean if you cut this, then what happens is again the two terminals, two poles will be formed. Again you will get two poles, north and south poles you will get. That is why if you cut this magnet into two, then also you will have two poles. That is why magnetic poles cannot be separated. That is what I have told in the previous class, that magnetic monopoles doesn't exist. So they will have always two poles. And in order to represent the magnetic field, we will draw some lines. That is known as magnetic field lines. This is the imaginary line will show the direction of the magnetic field. And here, the direction of magnetic field of a bar magnet, which is directed from north to south, it will be like this. North to south. This is the direction of magnetic field lines of a bar magnet. So these are some properties of a bar magnet. And this direction of a bar magnet was found with the help of a solenoid. You already know about the solenoid. Solenoid means it's a long wire which is wound in the form of a helix. So there we can draw the direction of magnetic field. And in the previous session, we already know about the direction of magnetic field with the help of applying the right hand rules. So with the help of that, we can draw the direction of bar magnet. Yes. Now, after knowing some properties of a bar magnet,